Hello, good day, students. I believe you are all prepared for the chapter 4. All right, now under this chapter, we shall be looking at how to deal with polynomials once it comes to math lab. Okay, yeah. So let's get to see how we get to find solutions to or roots to some polynomials in math lab. Okay, now remember from your algebra days, you guys were taught about the general form of an n-degree polynomial. Okay, so this happens to be the general form of any polynomial. Okay, so once we have a polynomial of this nature, how do we get to what compute this in MATLAB? And that is basically what this section or this chapter is about. Okay, now once you have any polynomial, be it of any word order, okay, it is being specified just like how we specify a vector in MATLAB. Okay, so as we can see in here, all that we need to specify is just what the coefficients. Okay, so in this case we are going to specify only the coefficients and just ignore the x variable. Okay, the x aspect of it, that is the one being raised to the others, and MATLAB automatically will identify that this is indeed a polynomial. Okay, and it can work with it straight away. Okay, so for instance, if we should have a cubic polynomial, okay, raised to the power 3, okay, we could write this in MATLAB as, remember, we are going to write only the coefficients. Okay, so in this case we are going to write 6, 2, 4 and 5. Okay, now this is just going to be the first term, second term, third term and the fourth term. Okay, so the first one will be a constant. This one happens to be the one with what, x, and this one is the second order with the s squared, and this one is the one sk. Okay, now let's move on to this one. This is a little bit tricky. Now with this one, you can see that in this case we don't have the x term raised to the power 3 in here. Okay, so once it happens so, and also we don't have the one with only x included. Okay, so in this case, once we are missing those aspects, it means that we have to introduce what, 0 to replace them. Okay, so this 5 happens to be the constant term. Because we don't have any x term in here, this place will be remembered or designated as 0. Now we do have the s square order of 2 coefficient to be 8, and that is what we have here. For the order of 3, we don't have any, so represented by 0, and the last one represented by what is coefficient, which is 5. Okay, now in that same case, if you should have negative coefficients, you can just introduce them as we see in here. And as you can see in here, we don't have one, the third and the fourth order terms in here, so they are being represented by 0. And the coefficient of the second order term happens to be negative 3, and the coefficient of the constant happens to be negative 9 too as well. Okay, in that same case, if you happen to have a square root, okay, you can use the square root function, that is the sqrt, and you specify the value. And so you can see in here we have square root of what, 7. If you should have a decimal or floating point into, you can just create it. Okay, now let's look at this special one, that is 6s5 raised to the power 5 plus 8. You can see that the others 1, 2 up to 4, all of them are missing, so that is why we have all these zeros in here. Okay, so that is how we get to specify polynomial once it comes to what, MATLAB. Okay, so let's see how we get to play with this. Okay, so suppose that we create this polynomial. Okay, that is 6x cubed plus 2s squared plus 4x plus 5 as we've designated in here. How do we get to estimate the functional evaluation of what, these polynomials? Okay, now in doing so, we make use of the function polyval. Okay, so for instance, in doing this in MATLAB, let's try to do same. Okay, Let me clear the screen. So suppose that we do have a function, let's call it as p, and we have polynomial or the coefficient of the polynomial to be 6, 2, 4, and 5. Okay. Once we do this, MATLAB automatically thinks of this as a vector and also as a polynomial. So if you would like to know the functional evaluation of this polynomial given a certain value of x, okay, suppose that we like to estimate the functional evaluation of this polynomial when x is equal to 2. We are going to make use of this function polyval, okay, then specify the polynomial, which is in this case p, and specify the value of our x. So if we like to estimate the functional evaluation of 2, they're just going to give us 69, okay. But what if we have a string of data and we like to estimate the functional evaluation? Remember we created a vector b, okay, and there's the input for the vector b. So if we would like to estimate the functional evaluation of all these points for each of every these points, okay, we could use this same argument, that is the polyval. Then we specify p, then you specify the vector b, okay. So they're just going to estimate the functional evaluation of these entries one at a time, and that is exactly what we have in here, okay. So that is also that. So that is exactly what we have down here, okay. Yeah. So after all this, what if you would like to plot the two, okay? So in this case, using the same polynomial, we were able to generate numbers, that is from -5 to +5, with an increment of 0.1, and we have another variable called the polyval, which is just going to estimate the functional evaluation of all these points we have in our x, okay. So once we have these two, you can just think about plotting them, and that is this beautiful plot that we have, okay. So let's get to see how we get to estimate the roots, okay. I believe you guys are aware of how we get to estimate the roots of polynomials, okay. So in this case, with this our polynomial, for us to estimate our roots, we are going to use the function roots. We specify the polynomial, and MATLAB is just going to calculate the root for us, okay. As simple as that. So in this case, our x1, x will be equal to 0.23, since 0.23, and our next one happens to be -0.8, okay. So that will be the root to this polynomial that we have, okay. Now what if you would like to generate a polynomial, that is the function, okay, based on a specified solution? So suppose that I would like to generate a polynomial which will give me some specific roots. I can just enter in the roots, and MATLAB in its own wisdom is going to generate a specific polynomial for me, such that if you should solve that polynomial, it's going to give you back that solution or roots that you just specify, okay. So in this case, we are going to, in doing that, we shall make use of the function poly, and specify the root, okay. So in this case, suppose that I would like to create a function that is going to give me roots as 3.5, 4.5, and 6. Using the poly function, I can just create this, specify this vector, and MATLAB is just going to create this should I say vector for us. Remember that this vector constitutes this polynomial, okay, and this happens to be s raised to the power 3 minus 14 plus 63.75 x, then minus 94.5, okay. And so that is exactly how MATLAB is going to generate this polynomial for us, okay. So with a given function or polynomial, what if you like to find the derivative of that function? Now this could easily be done using the poly dr, that is the poly derivative, okay. you specify the function, and MATLAB is just going to what? Find the derivative given you in this form, okay? Always remember that MATLAB is going to give you only the coefficient, but not the function, okay? So once it gives you the coefficient, you should be able to come up with what? A function. Yeah, so what if you like to integrate as well? You could use the function polyint to specify the function, and MATLAB will just what? Provide you with the coefficients of the terms of the integral part of it, okay? So this happens to be our integrated function based on what? This polynomial that we have, okay? Yeah, so that is that. So in this case, what if you like to multiply two polynomials, okay? Now in doing so, we use the function conv, okay? This conv, okay? So you specify the first polynomial and the second polynomial, and MATLAB is just going to multiply them for you, okay? So remember that all these have the same, they should have the same powers, okay? So don't forget that, okay? So MATLAB is just going to do this for you as simple as that, okay? So this happens to be our first one. So just multiplying these two polynomials, okay? So you just take this first one, multiply through, and take this second one, multiply through, and that is the answer that we are getting, which can be expressed as this polynomial, okay? So what if we like to also divide polynomials, okay? So suppose that we have this polynomial and we are going to divide by this x plus 3, okay? All that we have to do is just specify this polynomial as we have in here, and the polynomial below as we have in here. So once we specify the conv of polynomial 1 and polynomial 2, that is p1 and p2, as we've created in here, this is just going to create that, okay? But remember that if you are trying to divide polynomial or a function by another, remember that it's going to give you what? The remainder, and as well as what? The divider, okay? The dividend, okay? So in this case, you have to what? Specify two um, input, or let's say output parameters. So A and B, where the first one is going to give you the divisor, and the second one is going to just give you the remainder, okay? Or better still, if you should just enter in the conv of p1, p2, it's just going to give you these two straight away, okay? Now we could use polyfet, okay, to calculate the polynomial vector of n degree, okay, of any polynomial, okay? So if you like to fit any polynomial to any data, MATLAB can just do that for you using the polyfit function, okay? So suppose that we have these two vectors, that is x and y, we can fit a third order polynomial, and MATLAB is just going to generate the function or the equation for that polynomial down here for us, as simple as that, okay? So for instance, suppose that with these two vectors that we have, we plot these two together and we fit this polynomial, okay? MATLAB is just going to fit this polynomial. Remember, it's of the third order, and that is exactly what you see here. So MATLAB can fit that for you, and once we call in P is just going to display the function for this third order polynomial, okay? So let's see some basic things that we've learned so far once it comes to plotting. We could see that from our previous chapter that we could use the plot xy to plot any axis. We could plot the log where it's going to find the log of both axes. We could use the sum log x, the sum log y to transform the axis that we are interested in, okay? Now if you like to perform a linear function, we can use the polyfit xy, and remember this linear function is the same as what the first order, okay? If you like to perform a power function, that is the one that has been designated or written down here, so well as this other, as well as some exponential functions that we have in here, okay? Now we could also do the same using some other things as well, and that is exactly that we are saying here. Okay, so the power function, the log function, and that of what, the exponential function, these are the coefficients. Okay, all right, so that is that. And remember, with our subplot, okay, we could do some curve fitting down here. Okay, so in this case, we like to um, draw a polyfit of x and y log. Okay, remember we need one first order. Okay, so in this case we are generating data from 0 to 5 with an interval of or an increment of 0.01 and indicate all this as what, x new. Okay, now for the y new, we are going to find the functional evaluation of this function based on what, this x new that we just generated, and we are going to plot all this. Okay, so we are going to plot the x and the y that is from the previous. Okay, and this will be how we like the plot to be indicated. Okay, remember our x and y were just what, these elements or these vectors that we have here. Okay, so once we plot them, we like MATLAB to denote them at this round zeros. Okay, now in that same case, if you like to see stars instead of this round or circles, you could just, in place of this circle, you could just put the word plus, that is the symbol, and MATLAB is just going to change that for you. Okay, now for the second aspect of it, we like to plot the s new, that is this vector that we have here, and the next one happens to be the exponent of the y new. So this is going to find the exponent, and that is exactly what we have in here. Okay, so they're just going to plot the line for us. Okay, as we see in here. Okay, yeah, so let's see some of the other things that you can do once it comes to polynomials. You could fit so many things in there. Okay, so the first one happens to be the nearest. Okay, now this is going to just give you the nearest neighbor point. Okay, this is just going to fit a line. Okay, that is nearest neighbor point, so that if you are to interpolate, okay, the nearest neighbor to this number that you are looking for will be given to you. Okay, so for us to do interpolation, we are going to make use of the function inter p1. Okay, now we're going to specify the data. This is the original data. Okay, and that is the x new, the value in which we like to what, interpolate. Okay, and the kind of method. Now for the method, we have the nearest, the linear, the spline, and the cubic. Okay, and all these have ways of what, estimating their interpolated value. Okay, now this is something that you guys will learn one, I think, numerical analysis. Okay, interpolation, you guys will learn about this in there. That is the linear and the polynomial interpolations. Okay, we are going to learn all this in there. All right, so for instance, suppose that we have these two vectors, and that is what, x and y, and that is what has been plotted as our dots, that is our round. Okay, and we interpolate this new spline using x and y, and we are interested in interpolating from 0 to 5. Okay, and with this time we are choosing the splines, so that is exactly what we are seeing. Okay, so with this plot we can interpolate on any of these. Okay, suppose that we like to know the value of y at 2.5, that will be somewhere here, somewhere like 1 or so. Okay, so that is how we get to do interpolations. Okay, and this is very helpful once it comes to determining what, missing values. Okay, you can interpolate for missing values as well. So this brings us to our end of chapter 4. Okay, and hope that you guys will practice, just create or develop any sequence that you can think of. Okay, and just try playing along with this angle. Okay, and you shall get something. Okay, so this brings us to the end of chapter 4, and I'll see you guys for the next chapter, that is chapter 5. Okay, So enjoy your day and bye for now.